Okay, so it's already 4. It's already 4. So now we can join, we can start. No one has joined right now. So probably anybody can join later. So let me start. Okay, so let me start with sharing my screen. First, I have to connect this. Okay, so is it visible?
Yes, sir.
Okay. Okay, so do you have any question regarding the last lecture, last week lectures uploaded?
No.
Any doubt? Okay. So okay, so let me discuss the last question I discussed in the last week. That question again because probably there may be some doubt I felt. That's why I decided to discuss that question first. Then I will discuss the other question related to the last week lectures. Okay, so what was the question? Let me write it again. There was n number of non-interacting molecules. Okay, and that are distributed molecules are distributed among three non-degenerate levels. These molecules are essentially Maxwell-Boltzmann particles here. Okay, so three non-degenerate level. Okay, which are levels are epsilon 0 with energy 0, epsilon 1 with energy 1.38 into 10 to the power minus 21 joule, and epsilon 2 with energy 2.76 into 10 to the power minus 21 joule at 100 Kelvin temperature. So now, somebody, okay. Now, is the average total energy of the system that is given here at this temperature, obviously at this temperature, is that is given 1.38 into 10 to the power minus 18 joule. Then the number of molecules will be. Okay. So before discussing this question, let me discuss the Boltzmann distribution little bit. We know that, let's say there are various energy levels are there. For any ith level, what will be the population for ith level? Ni by capital N. Okay. If there is any doubt, you can ask me. Okay, regarding while doing this problem. Okay. So Ni by capital N. Now we know from our statistical mechanics from first week lecture that Pi is essentially e to the power minus beta epsilon I divided by q, right? So that is the also the probability of finding a particle at ith level. Okay, let's say this is ith level with energy epsilon I and population is pi. Some chats are there, right? Okay. Exam question pack. Okay, exam question pattern. For which exam? CSI, NET or GATE? You can unmute yourself and you can ask also. With Tom. Okay, for this course, for this question, exam pattern totally depends on the professor who is delivering this course. Totally depends on him. You may see the quiz question, right? So probably as per my knowledge, you have to select a center for exam, giving the exam, and you have to go there and MCQ pattern question will be there, just like question he is giving in the assignments, weekly assignments or quiz, that kind of question will be asked. But the number of question, the number of the timing, that I don't know because that is not fixed. That totally depends on professor. He will decide about the exam on this course. Good, because he is the instructor. But MCQ type of question will be there. There will be option. Okay, so this will be our population PI. Now, what is Q? Q is our partition function that is defined as, for making different notation without avoiding the confusion, I am using J instead of I. These are dummy variables, right? So it will be e to the power minus beta epsilon J. Now careful about one thing. The original formula is obviously Gi and here will be also Gj. If there is no degeneracy, then you should use instead of Gi, you can put 1, considering there is no degeneracy at all. Okay, so it will be e to the power minus beta ij. So if you put it, then you will have pi equals to ni divided by capital N equals to e to the power minus beta epsilon I divided by sum over j e to the power minus beta epsilon j. So this is our population, right? For now, from here, what you can write, ni equals to capital N in n into e to the power minus beta epsilon I divided by sum over j e to the power minus beta epsilon j. This is population for ith level. This is population. One thing, this is not population, this is probability, right? Probability of finding a particle. The meanings are the same, but for mathematical term, it means the probability. Means finding a particle at the ith level. That means Ni by capital N. Ni is the population of ith level. This is the population of ith level. And capital N is the total population. So it will be N into this formula. So this formula we can use. But let's say there are any other level also. So now we can write it. Two levels are there. Ni we have obtained. Let's say there is another level Nk. Okay. Or maybe Nj. Then make it K. These are all dummy variables, right? You can do this. There is no problem. All K, maybe I, maybe J, anything. Okay. So what will be then Nj? Nj will be N into e to the power minus beta epsilon J divided by sum over K e to the power minus beta epsilon K. Correct. This Ni and Nj. Now, if anybody want to calculate the relative population, Ni divided by Nj means the ratio of the population in the ith level and jth level, then that will be from, you have to take the ratio. So it will be e to the power minus beta epsilon I divided by e to the power minus beta epsilon J. Okay. So now you can write it is as e to the power minus beta epsilon I minus epsilon j. So from here you can write Ni equals to Nj into e to the power minus beta epsilon I epsilon j. So this formula I used yesterday directly, not yesterday, in last class. Directly I use this formula. This essentially, we generally use this formula for Boltzmann distribution. Actually, this is the Boltzmann distribution. Uh, this is the Boltzmann distribution. From here, you can evaluate this formula. That's why this also means the Boltzmann distribution. Because these all are the classical particle following the Maxwell-Boltzmann statistics. So you can say this is also Boltzmann distribution. Now you can write it. Let's say J is the zeroth level. So it may be anything. So from here, you can write Ni equals to N0 into e to the power minus into e to the power minus beta epsilon I minus epsilon 0. Okay, so this formula you can use or any level. You can use instead of nj you can put any level. So you can use this formula. Okay, now going into the problem. Say a non-interacting particle, Maxwell-Boltzmann particles are there, and three energy levels are there. What I used yesterday, let's say this value is epsilon. Then it will be 2 epsilon. Okay, so now 0, epsilon, 2 epsilon. Three energy levels are there, and n non-interacting particles are there. We have to find out this value of n. What they have given the total energy of the system or at its temperature is this. Okay, so last class we calculated the average value of energy. For any average, we know that the formula is sum over j for any average. Here energy, so Ej Pj. Correct. I discussed in last class considering the runs and matches. So we generally use the averages or mean using this formula. So this is average for one molecule. Okay. Now we have total n number of molecules. Then total energy will be n into this. Okay. This is molecular partition function, right? So for one molecule only. Correct. So this is the E average. So E average will be sum over j Ej Pj. And that means, so you can write it here. It will be E0 P0 plus E1 P1 plus E2 P2. So E0 is 0. So it is 0 plus epsilon P1 plus 2 epsilon P2. So you can write it epsilon into P1 plus 2 P2. So this is our E average. Now this value is also given. Now what is totally totally is this value, right? This value. So if you check, this is epsilon, and then it will be 1000 of epsilon or 10 to the power 3 into epsilon, because it's 10 to the minus 21, here it is 10 to the minus 18. So you can write it 1000 times epsilon equals to this formula we have to use, because this we have evaluated average of average of energy for one molecule. Then for n number of molecule, it will be n into epsilon P1 plus 2P2. So epsilon will be cancelled out. So you can write, okay, probably yes. Okay. Now this energy is for also, okay, this is for also the system energy. Look at here. This energy is also for the system. System means n non-interacting particles are there as well. So you have to multiply n here as well. So n will be essentially cancelled out. Okay. Probably this is clear. If you consider total system, then you have to multiply it with the capital N. Or if you consider only one particle or one molecule, then you can use this formula directly. Just multiplying with the number of particles. So this formula we know. We have one relation. P1 plus 2P2 is 1000. Okay. So now what we know from here, what is P1 and what is P2? P1 is N1 by capital N and P2 is N2 by capital N. So from here, you can find out that if you put it here, P1 and P2, then you will obtain this N1 plus 2N2 equals to 1000 N. Okay. So this formula we know. Yes, correct. One N will be there, probably one N. Okay. No, N epsilon is there. We have multiplied N here. Okay, this N will not be there. So. Yes. Now it's 3000 N. So it will be okay. These N terms create the misconception. This formula we need. Okay, correct. Here we have already multiplied N because this, let me clear it. Probably I create the mess. Okay, this epsilon is for one particle. Let me write it here for one particle or one molecule. Now for system, there are n number molecule. That's why we have to multiply it with n, then it will be for system. So this part is for system because this is for one molecule. When we have multiplied with n, this is for system. And this is already for system, it is mentioned here. This is for system already mentioned there. Here we should not multiply capital N again. That mistake I did. Okay, sorry. So here will be only one n, this side. N will be there. So from here you can write it. Okay, probably it's clear now. N1 plus 2N2 is 1000. Now, if N1 plus 2N2 is 1000, now we have to find out value of N1 and N2. Now we know what relation we know that Ni equals to Nj into e to the power minus beta epsilon I minus epsilon j. So, what will be for N1? Let's say j is 0, then it will be epsilon 1 minus epsilon 0. And epsilon 0 is 0, epsilon 1 is epsilon 2 is 2 epsilon. So if you write it, then it will be n0 e to the power minus beta epsilon. Similarly for n2, it will be n0 e to the power minus beta epsilon 2 minus epsilon 0. So it will be n0 into e to the power minus 2 beta epsilon. So now we have n1, we have n2, just put it. So n1 plus 2n2 is 1000. So it will be n0 into the power minus beta epsilon plus 2n2. So n2 in n0 into the power 2 beta epsilon equals to 1000. Okay, so from here you can find out n0. N0 will be 1000 divided by e to the power minus beta epsilon plus 2 into the power minus 2 beta epsilon. Okay, so this is our value of n0. Just we have to now calculate. How we can calculate that? We know beta. Beta is 1 by kbt. So e to the power minus beta epsilon, what will be the value? E to the power minus epsilon by kbt. And epsilon is given as 1.38 into 10 to the minus 21 joule. So let me write it 1.38 into 10 to the power minus 21 joule. And kbt, what is the value of kb? 1.38 into 10 to the power minus 23. And what is temperature? 100. So this will be again joule. So just look at it will be just 1. Correct? Because both are cancelled out. So it will be e to the power minus 1. Or you can write it 1 by. This is e to the power minus beta epsilon. So n0 will be 1000. Let common e to the power minus beta epsilon. It will be 1 plus 2 into e to the power minus. Because 2 beta epsilon. So e to the power 2 beta epsilon is there. So you can write it e to the power beta epsilon into 2 square of e to the power means 2 times, or you can directly calculate it from here. Let me calculate it. It will be better. 2 beta epsilon, so it will be 2 into epsilon by kbt. So it will be e to the power minus 2. So 1 by E square. Now it, directly you can write it N0 equals to 1000 divided by 1 by E plus 2 by E square. Okay. So if you do it, then it will be 1000 into E square divided by, doing LCM, it will be 2 plus E. This is N0. Okay. So now just we have to put the value. What will be the value? Okay. So it will be 1000 into E square divided by 2 plus E to the power 1. Okay. So it will be 1566. If I'm not wrong, let me check it again. You can also check by yourself whether this calculation is correct or not. 1 by E. Okay.
Whose value? E.
Yes, you can use the value of E in calculator. Just put the value of calculator, take 1 by E common first, then it will be easy. Then it will be 2 will be there because here is a 2. Yes, 2 is there. So 2 should be there. It will be minus beta is 1 by E if you put it. So it will be 2 by E. Right?
Yes.
Yes. Yes. 2 by E will be there. So now just you have to put the value of E. Then it will be 1000 into E divided by 1 plus 2 by E. So 1000 into E divided by 1 plus 2 by E. Just I'm putting the values in calculator. Nothing to do here. Yes, so it is 1566 approximately. 1566. This
Point
is the
zero four.
0.04. So just because this is number, this is not probability. So as it is number, we have to consider the integral value. So 1566. So now if n0 is known, so what was n1? N1 was is n0 into e to the power minus beta I, and e to the power minus beta is just e to the power minus 1. So you can write it. Directly you can do the math, or otherwise you can put this formula as well. Okay, so let me just do in the calculator divided by E. So it is 576.576 N1, and
Point zero
N2,
nine. That means point one.
no, point 1 will be there, but again we are calculating the number, na. So in case of number, we should consider the closest integral value. How you can say there is a 576.1 number of molecules? When it is
Is it
probability,
accurate?
accurate means, because you know that you have, when you have to take the closest value, let's say if it is 576, then you have to consider is 577, kind of that.
That's okay, no problem. But it's number or number of probability.
This is number of particle, not probability, because this P was the probability.
No,
This
no,
was the
the number of particle in the particular energy level.
number of particle in the particular energy level, Ni, population. When you divide it with
So
total
why
number of
so
molecules,
why I'm getting it's in fraction?
due to this problem, this is a mathematical problem. So doing numerical exercise, there will be errors. Okay, so that's why you have to take the closest value. You will not get exactly integral value. Okay,
But it is always exactly integral.
it should be. So that's why you have to approximate to the closest integral value.
Okay.
Okay, and n2 is n0 into e to the power minus 2 beta I. N0 e to the power minus 2, 1566 divided by e square. So it is only 77.96. So let 78. So this is the number of molecules. So we know now N1 we know, N2 we know, N0 we know. and there are only three levels. So total number of n will be obviously n0 plus n1 plus n2. So it will be 1566 plus 576 plus 78. So it will be 1566 plus. Okay, so 2220. Last time the answer was different. That's why I felt something may be wrong. That's why I decided to do it again. So this will be the total number of molecule.
But I'm getting different answer on the second.
Uh, which one? N2.
Yes,
What is the value?
210.58.
1566 divided by square, right? Yes. Okay, yes. Probably I missed something. 2000, 211, 12,
11.9.
12. Correct? Okay, do it.
Okay.
Because these answers are also not known to me. I formulated this question just.
If it doesn't match with the total number,
That you can cross check. This is totally you have to do as a numerical problem, and let's say you are forming you have built this question, construct this problem, so there is no option to verify it. Just how you can verify it? Three or four people do it and check the answers are matching or not. That in that way, that's why I'm saying you can try also, because I just formulated this problem based on the theory. In this tutorial I did not get the assignments. I have to make my assignments. Own assignment I get rarely. Tutors get own assignment, but unfortunately I got own assignment, so I have to build my own questions.
so I have one doubt. Should
Yeah.
I consider nearest integer, or should I consider with the fraction, and after calculating the total n, then I should choose the nearest integer?
No, no, no. In each cases, you have to choose the nearest integer because this is population at zero level. So you can't ignore, you can't consider the fractional value, never. Because one may ask the population at the ground level, then you have to answer this, right?
Okay.
In that way. So always you have to consider for each energy level the integer value, because that is a population, that is not probability. In case of probability, why this is coming, because I have not cross checked, right? When I have to make a question, I have to check it whether this is approaching to closest integer or not. I just put these values from my mind, these values. Obviously, making things consistent, but not exact, because this is actually value of kb. On you see this, this is coming from kb. So now kb
Yes.
values is already approximated. We can take the original total value of kb. So there are lots of approximated in numerical. In numerical problem, you will always see there will be approximation. So because calculator will not be allowed to your exam center for net or gate. Calculator will not be given. Gate probably given, but for net it will be not there. So you have to
Virtual.
approximate. Hmm?
Virtual.
What?
I'm talking about virtual calculator.
No, no, no. In CSINet, virtual calculator is also not that they gave in one exam, but after that they stopped this. So you have to learn for CSINet, you have to learn to approximate the calculation. That is very important. Just if you continue this problem considering this value, then you will be in trouble. Just you have to consider that is epsilon, and the values will be given in that manner only, so that you can approximate it. You can easily consider some variable, or by which you can do the problem very easily. They will give that scope, but you have to think by yourself and you have to streamline that question. Then only you can do. Otherwise it will take lots of time for one question. Let's say you took 10 or 15 minutes in CSINet, then it will be very difficult now, because you will only have 3 hours to do all the question.
But how one will calculate the value of e square or e in mind?
No, no, that value, if that is required, let's say if 1 by is required, then that value will be given in the question.
Okay.
That thing they will do, but in gate, nothing will be given, because in gate exam, calculator will be there. But in CSINet, they will form the question such a manner so that you don't need such calculated things, but you have to do the calculation streamline. That is very important to learn. Otherwise, it will take
In
more
jam,
time. Jam calculator will be given because jam and gate both are the constructed by IITs. No? So in that exams, calculator are given. In CSI net, calculator. Okay. Okay. So now question number two. Yes, Pritam, do you have any doubt?
না স্যার, না স্যার, ভুল করে হয়ে গেছে।
Okay. Okay. So now question number two. What will be change in partition function if the spacing between two energy levels or two successive energy levels? Okay. First is doubles, halves. Okay. So this is very straightforward question. We have to calculate the change in partition function. Okay. If the spacing between two energy levels, first option is doubles and halves.
what is
Okay.
spacing?
Spacing means energy gap. Energy levels are spaced, right? Like this. So these are spacing. Okay. Uh, Something let write. You have to write it for simple harmonic oscillator. Okay. This is very important for simple harmonic oscillator. You probably in first year you don't know, but later you will know that for simple harmonic oscillator, the energy levels will are equispaced. That is taught in the class for vibration equispaced energy level set taught. But that is for simple harmonic oscillator. That model is called simple harmonic oscillator model, for which all energy levels are equispaced. Okay, equispaced means the spacing between all energy levels are same, epsilon. If it is 0, then it will
Okay.
be epsilon, 2 epsilon, 3 epsilon, like this. This is not true for other cases. For rotational, later you will learn that for rotational cases or electronic cases. For those, this is not true. Even for this is for simple harmonic oscillator, but for asymmetric harmonic oscillators are there. Basically, for those also the energy levels are not equispaced. This model actually looks like this. It goes up to infinity.
Okay, I got it.
Mm. Okay, so here I am considering this simple harmonic oscillator model where all energy level are equispaced. So first, then what will be the partition function? What is the partition function for harmonic oscillator? That calculated in the lecture, it is 1 minus beta I. How you can do this? Let me also do little bit. It's not very difficult. We know this Q is J into e to the power minus beta Ej. As Gj is 1 for all j. There is no degeneracy. So you can write it. One thing you may do you have study simple harmonic oscillator?
No.
Okay. Actually, for simple harmonic oscillator, these energy levels are not like this. Okay. There is some approximation. Actual energy values are this is half h cross omega. like this. Let's say if this is not zero, I want to mean that, then it will be 3 by 2 h cross omega. It will be equispace is there like this.
N plus half h cross omega.
Yes, n plus half h cross omega. In general, this is the formula for
In which chapter
the
this is?
you a simple harmonic oscillator. You will study in that there is a 1D box, 2D box, quantum mechanics when you study. Then in case of quantum mechanics, after one dimensional, two-dimensional box, simple harmonic oscillator will become.
I
In
have
that
studied
chapter,
only to the 2D box only.
2D box. Okay, then 3D box, 2D and 3D box are just continuation of 1D box.
Yes,
So
yes.
after that,
Sorry. Yes.
you will there will be harmonic oscillator. So there 0 point energy is there. This is very important. Essentially, if you look at in 1D box or anything, translational energy, vibrational, rotational, for every energy, the 0 point energy means the energy for zeroth level is zero. But vibrational case, this is essentially model for vibrational, right? When you consider the
Yes.
vibration to molecules, that vibration is modeled as simple harmonic oscillator. In that case, the ground state energy is not zero. That's why that is called 0 point energy. This is non-zero. Okay, this is non half into h cross omega, not exact if you consider the exact thing. But here, for our simplicity, what we have done later, I will discuss that considering 0 point energy in next question, probably considering 0 point energy or without considering 0 point energy, what will be the changes that you can see. But you can approximate this like how, let me draw a figure, then it will be easier. Let's say, consider just four energy level, half h cross omega, 3 by 2 h cos omega, 5 by 2 h cos omega, and let's say 7 by 2 h cos omega. We can rescale, right? Because these level are all relative. Okay. Each energy level we have just shifted below with value half h cross omega. Then it will be 0. It will be h cross omega. It will be 2h cross omega, 3h cross omega, and something. For just our simplicity, we have did this. Sir also did this, right? If you uh, if you watch the videos for 1D box also, when he calculated the Q translational, then also he just, if you look at some value, he just subtracted to make the ground state energy zero. For 1D box also, the ground state energy is not zero. What is the formula? M square H square by 8 ml square, right? This is for 1D box.
Yes.
For E1, this is not zero. That's why he subtracted this value to make the ground state energy zero. This is called just shifting. These are actual energy levels. These are the actual energy levels. He just shifted. He gave us shift like this, and this is not wrong. Why I'm saying, because essentially we don't deal with the absolute value of the energies. This transition in chemistry or physics, these transitions are important, right? So for transition, the energy gap is important, not the absolute value of energy. Also thermodynamics, you will
Yes.
later see that delta is these delta things are important. So that's why when you
Only
shift
change.
only change all energy levels with a relative shift, then essentially overall essence will be the same. Okay, that's why you can do this. But for absolute value, if you want to consider the absolute value, then obviously this is wrong. This is obviously approximation. This is, you have to consider the actual value. But okay, it's okay. You can do this. There will be error, but that will be not very significant. So that's why he considered this is as 0, epsilon 2, epsilon 3, epsilon 4, epsilon something like this. So then you can do it easily. The ground state as it is 0, so it will be 1 plus e to the power minus beta epsilon, e to the power minus 2 beta epsilon, and so on. Okay, so now if you consider e to the power minus beta epsilon as x, then it is just a 1 plus x square plus x cube. Okay, like this. So you can write it, it is as 1 by 1 minus x. Okay, you can approx this because you are first year. So do you have studied the series and sequence? Probably not. So in series and
Yes.
series and
Yes.
you studied. Okay, great. So you know this. This is a approximated, right? Not when
Expansion.
expansion, but this is valid when x is very, very less than 1.
Yes.
Otherwise, this is not valid. If you consider, let's say x is half, just half, then you can't match these values. Why I am saying this is a sequence, right? Series. You are adding things, so it should be converge. Then only you can give a value, right? If it is not converging, x if it is x half, then it will be half plus half square plus half cube. It will be goes on. So in that case, the convergence will be, there is something called radius of convergence, but that will be very large. So this will be very accurate, this approximation, when x is very, very less than 1. In that case, you can do, just consider for this value, just consider, let's say x equals to 2. If x equals to 2, then it is, if x is greater than 1, then you can't do this. Let me just connect the charger. Uh,
Then it will be invalid. Negative it will be.
yes, it will be negative, and this formula 1 by 1 minus s, this is actually valid. While deriving this formula, you have to consider x is less than 1. And when x is very, very less than 1, then it is very accurate. So, and here x is e to the power minus beta epsilon. So just you can calculate that value. This is obviously less than 1, and also not very, very less than 1, but it will be always less than 1. So you can do this. So it is 1 by 1 minus x. So you can write it 1 by e to the power minus beta epsilon. So this is our partition function, or you can say it QV, because these are vibrational. Although sir did not mention in class, as levels are vibrational levels, so it is actually the QV. Okay, so let me write it. Just now, what is the question? Question was this partition function, if spacing is changed and just if doubles. If spacing is doubles, let's say it is Q0, and when spacing is will be double, then it will be e to the minus 2 beta epsilon. So what is the changes? Just you okay. Some network issue was there. You can see on my screen. Here, weather is very bad today also. Okay. Okay, now is it visible?
Yes.
Okay. So just you have to take now the ratio Q1 by Q0. So it is 1 minus e to the power minus beta epsilon divided by 1 minus e to the power minus 2 beta epsilon. So this is the change. Now, if you have the value of epsilon or beta epsilon, then for our convenience, we can consider the value from the last problem. What was the value of last problem? Just for checking. This was the e to the minus beta epsilon, it is 1 by e. So if you put it, then it will be Q1 by Q0 will be 1 minus 1 by e, and it is 1 minus 1 by
2 by square.
no, 2 by square will be there. No, no, no. 1, because it is e to the power minus beta is e to the power minus 1. E to the power minus 2 beta e will be e to the power minus 2.
Okay.
It's just square. So it is like this. So just now it is e minus 1 by e. It is square minus 1 by square. So it is minus 1 divided by e into e square divided by e plus 1 e minus 1. So it is e by 1 plus e. So this is the change. Okay. When it is doubled. Now if it is half, then it is, let's say, Q0 we know. Q0 is 1 by 1 minus e minus beta epsilon. And if half, let's say it is Q2, then it is 1 by 1 minus beta. Instead of epsilon, it will be epsilon by 2. Okay. So if it is epsilon by 2, now again you have to calculate Q2 by Q0. So it is 1 minus e to the power minus beta epsilon by 2 divided by 1 minus e to the power minus beta epsilon. Again, you can consider the value from above equation, above problem. So it will be then Q2 by Q0 1 minus, okay,
So
Q2
root E.
probably this will be right.
Yes.
Uh, so yes, 1 this is
E to the power minus 1.
e to the minus 1 or 1 by e, then it will be by 2.
E to
So
the
it is
power
by e
minus
to
half.
the, yeah, exactly. So it is e to the power minus half. So it is, let me write. So it is e to the power minus 1, and it is e to the power minus half. So it is 1 by 1 minus e, 1 by, what will be this? E to the power minus half means 1
1
by
by
e,
root E.
1 by half, e to the power half. So it is 1 by e. So 1 by e. Now again you have to take the LCM. So it is this root e minus 1 divided by root e. So it is e to the power minus. How can you can write e to the power minus 1? This is like this into root e divided by root 2 I to the power minus 1 into e. So essentially it will be, this will be cancelled out.
Root E by root E
Yes,
plus 1 by root. Yes.
exactly. So or you can approximate it as 1 plus 1 by root e. So this is the changes. So if you check, this is greater than 1 or less than 1,
Which one?
this value
Less than 1.
less than 1, because this is 1 plus e. So you can write q1 by q0 is less than 1, whereas this is greater than 1. q2 by q0 is greater than 1. So when the spacing is increased, then partition function, so you can write it q1 is less than q0, right? So partition function decreased, but when the spacing is decreased, partition function increased. So it's totally depends on the spacing between the energy levels for simple harmonic oscillator. If the spacing between energy level increases, the partition function decreases. Okay. So the spacing is very important, and this spacing is actually the characteristics property of molecule. Which molecule you are taking, because this is vibrational, right? As I mentioned, if it is iodine, if it is hydrogen, if it is nitrogen, for each cases, this value will be changed. This epsilon value will be changed. The spacing is changing. So according, using that value, we can check the whether the partition function for which molecule the partition function will be much or less. You can compare. So that's why this is very important. Okay. So now going to third question. So that question I was talking about, I have to do it first. Okay. Now calculate the partition function for simple harmonic oscillator considering 0 point energy and without considering partition function and population, let's say. So population as well. And without considering 0 point energy. That discussion we already did, but we have to now calculate it. Without considering 0 point energy, no. Without considering 0 point energy, without considering 0 point, okay, just q. This we have already calculated. This is 1 by e to the power minus beta epsilon. This is our q. Now what will be the population?
Epsilon J.
No, this is partition function.
Okay.
Partition function means sum over the all this formula. This is not population. This is partition function. But when you have to calculate
So
the,
why there is epsilon only?
that we have already discussed now. If you do it, then what is coming here?
Oh, this approximate value. Okay.
No, because we are considering the simple harmonic oscillator. That's why this epsilon is there. Epsilon is the spacing between the levels. That's why
Okay.
epsilon is coming. Okay. So all epsilon SHO is mentioned here. Now for population, then you have to consider the J or I. So then it will be e to the power minus beta epsilon J divided by Q, or Q is, let me write it Q. So it is 1 into e to the power minus beta epsilon into the power minus beta epsilon. So it is Pj. Here I didn't use the Gj because degeneracy is 1. So it's there. Okay, but this calculation is considering without considering the 0 point energy. Now, considering 0 point energy, how you can do? I I'll give you the hint. You should try. If you can't do it, then in next class I will discuss. So what will be the procedure? Procedure will be the same, but now the energy levels will be like this: half h cross omega, 3 by 2 h cross omega, 5 by 2 h cross omega, or something. For convenience, you can consider this as E or epsilon, half epsilon, 3 by 2 epsilon, 5 by 2 epsilon, 7 by 2 epsilon, like this. So now the
In the
partition
previous one,
in the previous one, we did not consider this half. We just subtracted this value and make it 0, changes to 0.
we started
This
from 3 by 2.
No, let let subtract for each energy level, this 0 point energy level, you have to subtract. This is the 0 point energy, right? So then
Yes.
it will be 0, then it will be epsilon, it will be 2 epsilons, like this. If you if you
Okay, that means
subtract this
after
value,
considering 0 point energy, all is getting changed.
yes, just if you consider 0 point energy, every level will be shifted with that value. If you don't consider it,
Okay.
then just see each and every energy level just shifted downwards with that value. This will be 4 epsilon. This is just relative changes. You have just shifted the values, but this is the actual. This is the actual energy levels, because 0 point energy is there. But if you ignore the 0 point
Yes.
energy, then you have to consider these energy levels. This we have already discussed using these values. Using these values, we have already discussed. But when there is 0 point energy, you have to consider this 0 point energy as well. If you use that, then the partition function, the definition of partition function will be the same. But here you have to consider now e to will be e to the power minus beta. What is the ej or e0? Then you have to consider this e0, e to the minus if it is beta e1, e to the minus beta e2, in this way. And e0 is epsilon by 2, epsilon by 2, e to the minus beta, it will be 3 epsilon
3
by
epsilon
2,
by 2.
5 epsilon by 2. In this way, you have to do it. Okay,
Okay.
so now how you can do? Just take common,
Beta
then
epsilon by 2.
it will be,
Same as the previous one.
what will be the power? Beta e,
1, then e to the power
then
minus 2 beta e.
yes, and so on. This part we have already
Yes.
did.
Yes.
This part we know. So what is the value? 1 by 1 minus e to the minus beta e. So this is the actual value considering the 0 point energy. Without considering 0 point energy, this numerator was 1. But if you consider the 0 point energy, the numerator will be e to the power minus beta epsilon by 2. This is the change. Okay. So eventually the population also be changed. The population will be Pj will be e to the power minus beta ej divided by q. So now it is 1 into e to the power minus beta epsilon divided by e to the power minus beta epsilon by 2 into e to the power minus beta h. This is the population. Okay, is it clear?
Okay.
So this derivation is also important. Just nothing, just you have to take the common, everything will be then same. just from here also you can see what this is, you are taking this common, right? That means that
Yes.
you are just shifting that value. When this is not there, that means the shifting you are ignoring. You are adding the 0 point
Yes.
energy, that means this epsilon by 2, this half epsilon, just this value you have, this is the 0 point energy half epsilon, this you have just added to every term. Essentially this means. But for our simplicity, we don't consider the, we just consider this as one
Yes,
without.
but this is the real one because it has zero point energy.
This is the correct one. This is the correct one. While doing the numerical problem, you can see that this value will be very less because this is epsilon by 2. So compared to this value, that's why you can also ignore. But for the actual value, you have to consider this. Okay. So this was question number, I think, that's the question number 3. Okay. 4. Now, find out the inverse temperature for which P1 becomes 10% of P0 for simple harmonious filter. Okay.
Okay.
So what is the inverse temperature? You can try it. It is very easy question.
PB1 means the population of the first state.
Yes.
I mean probability
Not probability, population.
population. Okay.
Same. Because we are considering the 10%. That means the ratio between the population. So eventually P1 and N1 will be equivalent here. Here actually this is the probability of, you can consider probability or population, both will be fine, no problem. Generally P means the probability. So first you have to understand the what does it mean by inverse temperature. Do you know the definition of inverse temperature?
I forgot it.
Nothing. Beta is called inverse temperature, not the 1 by T.
Oh, I
It is
remember.
1 by kBT. Beta is called inverse temperature. Now it's very easy, nothing is there. So just there is one catch, you have to know the definition of inverse temperature. If you do it 1 by T, then everything will be wrong. Also, you can check it from the value of energy unit. From unit you can check, because if it is a Kelvin inverse, then it is just, but it is actually the Joule inverse. Because kBT is Joule, so it is Joule inverse. Okay, so how you can do? Now we know P1 or Pj, anything, we know that e to the power minus beta epsilon j divided by Q. Okay. So now it is Pj. So for P1, it will be, this is population, right? P1 is not population, probability. It is P epsilon 1 divided by Q. And for P0, it is e to the power minus beta epsilon 0 by Q. Now you just do it. So we have to do P1 by P0. It is e to the power minus beta epsilon 1 minus epsilon 0. Okay. So this is our, we have now 10% of P0. So 10% of P0 means P1 is just 10%, 10 into P0 by 100. So P1 by P0 is 1 by 10 equals to e to the power minus beta epsilon 1 minus epsilon 0. So epsilon 1 minus epsilon 0, you know the value. What is the value? That is epsilon gap. Here you can consider the 0 point energy, or you, that does not matter, because here this is a difference between the E1 and E0, and
Yes.
that will be remain same for both cases. What will be the value? Epsilon for both cases.
Epsilon for
So that's why I said, because most of the cases the difference is important. So e to the power minus beta epsilon. So Here from here you can count that e to the power beta epsilon will be 10. Correct? So take log. So take log ln 10. So beta epsilon is ln 10. You have to calculate the beta. It is 1 by epsilon into ln 10 or ln 10 by epsilon. Clear? This is the inverse temperature. General definition.
Okay.
If you have the value of epsilon, you just put it and see ln 10 is a number, there is no unit. So beta will have the inverse unit of the energy. And energy has the unit of joule, so it will be just joule inverse or something like that. Okay. So this is also very tricky question. Just you have to know the value of inverse definition of inverse temperature. Okay, so it was question number 4. Okay, 5. Let us do some easy question now. From straightforward question. Okay, let me find it. So, 5. Yes. Mhm. Okay, this we have already discussed, so leave it. Okay. This type of question we have already done, already did in the last class, but still, one molecule has a ground state and two excited state for energy levels, all of which are non-degenerate. With the energies, epsilon 0 is 0, epsilon 1 is 1 into 10 to the power 10 joule, epsilon 2 is 3, 3 into 10 to the power minus, okay, it is not 10, 20 joule. If P0, P1 and P2 are the fractions means probability of molecules occupied in the ground first and second excited state respectively at 298 Kelvin, then find P0 is to P1 is to P2. Okay, this type of question we have already did. You can try, then I can solve. Okay.
Can you please scroll up? Total energy of the system is not given.
No, that you can add E0 plus epsilon 1 plus epsilon 2. Okay, let me proceed. You can check the answer. It's not very difficult question. Just calculation. Okay.
Okay, I'm also doing it.
Yes. It is better than I can also check. I can also verify. So there are three energy levels. Let's say it is 0 because it's given as 0. Let's consider this value as epsilon and this will be then 3 epsilon. So it will be epsilon, it will be 3 epsilon. So there are three energy levels are there. So now P0, P1, P2 we have to calculate. So what will be P1 or any Pj, it will be e to the power minus beta epsilon j divided by Q. And Q is the partition function. Q is sum over j e to the power minus beta epsilon j means 1 plus e to
Plus
the
x
power
plus
minus beta e to the power minus
2 beta e.
3 beta e.
Sorry, 3 beta e.
Yes. 3 beta e. So this is the case. So what will be now P1 or what will be P0 first? So it is e to the power minus beta epsilon 0, which is 1 divided by Q. P1 is e to the power minus beta epsilon e divided by Q, and P2 is e to
To
the
the
power
power minus
minus
3 beta epsilon by q.
by Q. So now we have to find out the ratio like this. So it will be 1 is to e to the power minus beta e, this is minus 3 beta e. I have to put the value beta e. What will be to the power minus beta e? It is e to the
E to the
power
power minus 1.
kBt. No. What is the value of epsilon? 1 into 10 to the minus 20. So it is 1 into 10 to the minus 20, and kb is 1.38 into 10 to the minus
8 into 10 to the
23,
power minus 23.
and T is, what is T?
298 Kelvin.
298 Kelvin. So 298. So
I
it
am
is,
stuck at here.
okay, just you have to use the calculator. Otherwise, so it will be 1 divided by 1.38 divided by 298. So it is 2 point e to the power minus 2.431 into 10 to the power minus 3 into minus 20, then it will be, so essentially it will be cancelled. So just this, it will be minus 2.413. So it is minus 2.413, it is 0.0879. So P0, P1, P2 is 1 is to 0.0879, and it is cube of this. So if you do
Yes.
cube of this, then it will be to the power 3. So it is 0.000682. So this will be the answer. That's the populations. Here we don't need to calculate the partition function even, because while taking the ratio, the partition function will be cancelled out. So that's why I did not
Yes.
calculate the partition function. That is not required. Okay, so this was question number 5. Okay, what is the translational partition function of a H2 molecule confined na 100 ml flask at 1298 Kelvin. That is given the molecular weight of H2, and that is 2.016. So can you do it?
Radius
What?
radius of H2 molecule
That will not be needed.
for moment of inertia.
Why moment of inertia will be needed?
Oh, sorry. That is rotational function. No.
Translational partition function.
Okay, sorry.
Rotational partition function till now introduced in class. In next week probably.
Please write down the formula that I can cross check.
Okay. So for Q trans or Qt, whatever you want to write. What is the formula? V by lambda cube, or explicitly you can write it 2 pi m kbt divided by square to the power 3 by
4 to
2
the 3 by 2. Okay.
v. It's totally formula based question. This type of question can also ask. All questions are not tricky. Some question will be all straightforward. But here you have to remind this formula.
I reminded it.
Hmm.
Only this question only.
Yes. Okay, just let me put the values. Nothing is there. One thing only you have to keep in mind, that m. Don't put m 2.016. Here, this is the partition function for a molecule. So you have to deal with a single molecule, single H2 molecule. So you have to consider the
Divide by
mass.
Avogadro's number.
Exactly. Divided by Avogadro numbers. So m is 2.016 divided by m. That you have to put it. Otherwise, everything is correct. These things, these mistakes are very common because that option will be available without using that NA. So it is 2 into
In
pi
exam,
in exam. So because I also did same kind of mistake. Okay, for two things are there while calculating this m, and later when you calculate the inertia I, there is mu, right? Mu r
yes,
square.
reduce mass.
Reduced mass. In case of reduced mass also you have to consider that Na. You may think that that is ratio, but actually mu is m1 m2 divided by m1 plus m2. So 1 Na will be left. So in that case also you can't ignore that Na. You have to also consider. From that two places, Na are oftenly missed out. Obviously the answer will be wrong. So m is 2.016 kb. What is kb? 1.38
1.38 into 10 to the power minus
minus
23.
23. And T is also given, probably T is 1298 Kelvin divided by Na will be there because Na I didn't write it here, 0.622 10 to the power 23, and 8 square 0.626 since the minus 34 square into V. Okay, V is 100 ml flask. So that also we have to convert. V is 100 ml equals to 100
Decimi cube.
no centimeter
Oh,
cube.
sorry, centimeter cube.
So now 1 centimeter equals 10 to the power minus 2 meter. So it will be 100 into 10 to the power minus 6
6 meter cube.
meter cube. So it is eventually 10 to the minus 4 meter cube. So it will be 10 to the power minus 4. So just now you have to calculate this value. It will be 2 into pi 2.016 1.38 into 1298 divided by 6 and 0 by 6.6. Yeah, so it is okay. Some here is 3 by 2. Okay, you can also do one thing is missed here. 10 to the minus 3 is coming from where? 23 2 pi m. Is everything correct? Here anything missed? 2 pi there, m is 2.06, 10 to the 20. Okay, okay, okay,
What is?
okay. This is
Oh,
also important because this value is in gram, right?
yes.
So we have to consider in kilogram. These mistakes is very of very common mistakes. So here you have to consider 10 to the power minus 3. Okay. So now if you do it, so it will be 8.58184 to the power 3 by 2 into 10 to the power minus 4. So it is just 2.514 into 10 to the power 27. No, this is correct, but now we have to consider the power. Power I didn't consider. It is 23 minus 3, 26. Here is 23 again. So it will be 10 to the power. Let me do it. 10 to the power minus 23 minus 3 minus 23 again plus 34 plus 34. So 19. 19 to the power 3 by 2. So 10 to the power minus 19
To the power 3 by 2.
to the power 3 by 2. 19 is not a good number. 90 is
I
not.
think that's problem something, but I also getting the same.
No, but where? If you are getting the same, then probably it's correct. Okay,
I'm
no,
also
10 to
getting.
the power, no, 10 to the power minus 3 we have considered here. Okay, in this value.
Oh, sorry, sorry.
That's why 10 to the minus 3 will not be there. So then it will be 16, I think. If 10 to the minus 3 is not there, so it is 10 to the minus 16. 23, 23, 46, and 34, 34. So it is
No, it's 22.
it's 22. 22. Anything, maybe. 22, then 2, you can divide it, right? So then it will be, it's plus 22. It is plus 22. Check it.
Yes.
23 plus. Yes, so it is 10.58 in 8, 4, 3 by 2 uh, into 10 to the power minus 4 into 10 to the power 33. Now it's done. So if you do it, so it is 8.58184 into 3 by 2 into 10 to the power 29. So it is 8.58184 to the power 3 by 2. So it is 25.140 10 to the power 29. Or you can write it. Correct?
Yes.
Oh, so this is the value of translation. Translation partition function always have this kind of value order 10 to the power 20, 30, kind of this. Okay, so now question number 7. This is easy. Wait. find out the, just I'm writing code, right? Then I will explain the question. Uh, y when x equals to z uh, for a three-dimension 3D box like this. How the box is? Box has three edges. One edge is, length of one edge is x, one edge is z, another one is y. So three edges are different for that three-dimensional box. So you have to find out the y. X and z are
But
equal.
two are same.
Two are same. X and z are same. But the definition, just I draw the basic general box. This is x, y, and z. Then you have to calculate what is given. Given that q, just see it, q unsymmetrical equals to 0.8 q symmetrical, where for symmetrical box the edge is 2 root z. Clear?
Yes.
So we have to calculate it. It's now there are two type of box, right? First is symmetrical box. Symmetrical box means cubic box. All edges are equal.
X equal to y equal to z.
X equal to y equal to z. Correct. Okay, so here all edges are a. Let's say a. Then what will be our partition function? Here translation partition function. These are all translation partition function. Okay, qt. So what will be the qt for the symmetric box? What is the formula?
Energy.
No, for partition function. This formula will be needed, no? This is the formula for partition function. So it is, let's consider it will be just 1 by lambda cube. So it is v by lambda cube. Because you see, this lambda is totally independent of the box. It may be a symmetrical box, it may be an unsymmetrical box, but this lambda is same. This does not depend on that. So you can consider this just v by lambda cube, and v will be a cube by lambda cube,
Yes.
and a is root 2 z. So you can write it root 2 z cube divided by lambda cube. So it is 2 root 2. Oh no, it is 2 root z. Sorry, it is 2. Yes, it is 2 root z. So it is 2 root z. So it is 8 z root z divided by lambda cube. So it is q translational for symmetric box. Now for asymmetric box or unsymmetrical box, whatever you want to write.
It is always 2 root z.
No, here it is mentioned now. Age is mentioned
Okay.
here. 2 root z in the question. So for unsymmetrical box. So here the ages are not the same. X, Y, Z you have to consider. That is already given in the question. So here X, anything X, here Z, Y. So here the Q will be Q translational unsymmetrical. That will be again V by lambda
0.5.
cube. So V will here V is X, Y, Z divided by lambda cube.
Yes.
So X and Z are same. So Z square Y divided by lambda cube.
Yes.
Now you know what is given, that Q unsymmetrical equals to 0.8 into Q symmetrical.
Symmetrical.
So Q unsymmetrical is z square y divided by lambda cube, and Q symmetrical is 8 z root z divided by lambda cube. So lambda cube will not be there essentially. Okay. So here from here you can calculate the 8. So it is 0.64, sorry, 6.4 into 1 z will be cancelled out. So let me write it. Z so divided by z square. So it is 6.4 into root z by z. So it is this. Okay. So this will
Why
be
it's
the
6.4?
8 into 0.8. What will be?
Okay, okay.
So this is the value of y. So 6.4 by root z. Okay. So this is very good question. Means this is not direct numerical question, but conceptual question. Just you have to keep in mind that this lambda will be cancelled out. It does not matter. Okay. So this is question number 7. So now 8.
Why it doesn't matter? Because it has m and that also.
No, m is the mass of the molecule. So that means which molecule you are making confined in it. So that is same. Just box is changing. Okay. In thermodynamics, you studied na, that extensive property and intensive property.
Yes,
Extensive property means that are independent of the
mass of the
mass
system.
mass of the system. So that is that mass is coming due to m is present, right? But only if you look at, actually that is not true. Not only mass. What I want to say, for extensive property, give example of extensive property. Volume is an extensive.
Density.
No, density is intensive, independent of mass. Mu,
Oh, sorry, sorry. Yes,
density, when that divided with the mass, that does not depend
mass
on the
itself.
mass itself. Mass, volume, energy, internal energy, enthalpy, these are all extensive property, right? So here all partition function are intensive property, except this translational partition function, because the volume is here. This mass is not property of a system. If you later, when you the partition function of the rotational partition function will be, formula will be known, then you can see in the rotation partition function also m is there, because I is there.
Yes.
But that is property of the molecule, which are you confining it. Okay, but that is not dependent on the mass of the system or volume of the system. But here the translational partition function depends on the volume of the system, which flask you are considering or which volume you are taking.
If
So
the
that,
size of the box is changing, then the mass of the molecule also is changing because there will contain more molecule.
no, this is for only one molecule. This is molecular
Okay,
partition function.
okay, then it's right.
That that's why it's totally, this is only the, this question is also common. The translational partition function is only extensive partition function. All partition function other than translational partition function are intensive. That does not depend on the volume. Okay. So now, okay, what will be the question? Question number 8. Okay. So now going in. Question number 1. 1, 3, 4. Let me find out the question first. Let me see. Okay. This also discussed in the class, but the general form, it's important to discuss, I think. When t tends to 0, value of the single particle partition function will be, what is given? Given that degeneracy degeneracy of level J is Gj. So what will be the answer?
1.
No.
T tends to 0, the function was 1, and for infinity it's 0.
That's why I did this question. That is one when there is no degeneracy. There is degeneracy, right?
Yes, yes,
So what is the formula? That Q is Gj e to the power minus beta Ej. So if
yes,
you expand it, then it will be Z0 plus G1 into the power minus beta epsilon 1 plus Z2 into the power minus beta epsilon 2 and so on. So when T is 0, so as beta will goes into infinity because beta is 1 by kBt.
yes,
So if T tends to 0, beta tends to infinity, that means this term will be e to the
0.
power minus infinity. So it is 0. So each term will be 0, only Z0 will be there. So Z0 will be answer. So not the 0, not the 1. If there is no degeneracy, then it will be 1. Otherwise, no. Okay.
Okay.
Now, but if then, let's say, this is again, if you can, this is true again for the part, let's say if you're considering the harmonic oscillator, as I discussed, this is true when the ground state energy is 0, correct?
Yes,
But
because it
we
is
know,
1.
yes, but we know originally the formula will be G0 into e to the power minus beta epsilon
Beta
0.
epsilon j.
So the correct answer is this. Because you don't know whether the ground state energy will be 0 or not. If it is 0, then it will be Z0 eventually. But if it is not Z0, then you have to consider that value even.
Yes,
Okay. So this is, and what will be the probability of that means P0?
e to the power minus beta epsilon j by q.
Epsilon 0 by Q. So just put it. So it is e to the minus beta epsilon 0 divided by Z0 into the minus beta epsilon 0. So it is 1 by Z0. Okay. So generally we obtain the value 1 because we consider the degeneracy is 1. That's why non-degenerate level we consider. Okay, but in case of degeneracy, you have to consider this formula. So
It was
similarly,
tricky.
it was tricky, but this is very important because in question originally we don't consider the G because we consider okay it's a harmonic oscillator or something else, so we don't know, so it is 1 non-degenerate levels are there, but essentially the general formula we have to consider. So now if it is T infinity, then if what will be the changes in case of T infinity? So one thing you can see from here, it is P0, right? So P, and what will be Pj not equals to 0? Then it will be to the minus beta epsilon j divided by q. And you know that this term will be 0, right? This term for
Yes,
all cases. So it will be 0. It essentially means all energy levels are vacant, only the ground state is filled. There is only the
completely filled.
limitation. All molecules are there.
Yes,
But if it is here, you can see this is just non-degenerate. But let's say the ground state is degenerate. Then you can't say that both energy levels are all molecules are there. That's why 1 by G is coming. If there is degeneracy 2, then what will be the probability? Half.
yes,
That's why here it will be splitted. Get it? This is the essence of this
yes.
formula. Okay. So now going T tends to infinity.
All level will get equal amount of molecule.
But what will be the value, numerical value? Again, you can write this is Q will be sum over J to the power Gj into the power minus beta Ej. So it will be Z0 e to the power minus beta epsilon 0, G1 to the minus beta epsilon 1, and so on. No, let me write one.
G0 plus G1 plus G2.
because all these will be, because t tends to infinity means that beta tends to 0. If beta tends to 0, then it will be
1.
1. So it is z0. After that, it will be again 0
Yes.
because beta is 0, right? So e to the power minus 0 is e to the power 0, 1. So g1 plus g2 and so on. So you can write it this. And what will be the probability? Pj will be e to the power minus gj into e to the power minus beta ej. Here also you have to consider the gj event divided by q. So it is gj e to the power minus beta epsilon j divided by sum over j gj. So we can write it gj by sum over j gj e to the minus beta. Okay, so this will be the probability. So you can see whether it will be same or different, because this value, you know, what is the value? It will be minus beta ej 1.
1.
So it will be not there. So it is same. So gj by so pj that will depends on the degeneracy, obviously. Otherwise, it is same for this is for a level, right? Because this we have discussed, because there are g number of levels, degeneracy is there. That's why it's multiplied with j. But for a single state, what will be then? Let's say for ith state, it will be 1 by e to the power j gj, because we know states into degeneracy equals to levels, right? So
Yes.
finding state pi into gi equals to level, that was this value. So that's why this gi will not be there in case of level. So gi will be cancelled out. So when you are talking about states, then there will be no degeneracy, obviously. But in case of level, you have to consider the degeneracy. Okay. So again, it's a good question. After question 8, 9. This is again a straightforward question. Formula bit. This question translational. Cartesian function of hydrogen atom is unit is 10 to the power 33 at 3700 Kelvin in a volume of 0.064 meter cube. What is the thermal wavelength value in meter? So it's totally formula based question. You just try. Okay,
Thermal wavelength means lambda.
lambda. Just wait a minute. I'm coming from it. You try. Okay, we connect it means. So what will be the value?
I am calculating it.
Okay, let me also do. You can check. So Q translational will be, as we have discussed, 2 pi m kBT divided by E square
H square whole to the power 3 by 2 into V.
into V. Means V by lambda cube, right? Where lambda is
Yes.
called the thermal wavelength that we have to calculate here. That is this value. Okay. So just put the values. So what we have the partition function. So Qt that is given as 8 into 10 to the power 33. So that will be essentially uh, V by lambda cube. So lambda cube will be V by 8 into 10 to the power 33. Okay. So V lambda will be this. So now V. What is V? V also given 0.064 meter cube. So it is 0.064 divided by 8 into 10 to the power 33 divided by 1 by 3. To the power 1 by 3. So 0.064 divided by 8. So it is to the power 1 by 3. So it is 0.2 into 10 to the power minus 11. So you can write it 2 into 10 to the power minus 12. Obviously,
Minus 12.
this is very straightforward from this question.
But
Formula
that's only
discussion. That's it. You have to find the thermal wavelength.
2 pi m kBT. That's
That is not given. We can calculate from both. If that is given, then from that formula you have to use. But here the translational partition function is given. So you have to use this formula.
we know everything here.
Yes, we go. But using this formula you can't do. KB you know, T you know,
Why?
M you don't know.
2.016.
Yes, yes, you know. For hydrogen atom it's new. Yes, from using that value also you can do. Check it whether it is same or different. Probably it will be same because just using that value the particle function is calculated. Let me also do H divided by H is 6.626. Okay, root over 2 pi m. M will be for hydrogen atom. Okay, so it is 1 into 10 to the power minus 3 by m. Maybe T is given. Yes, 3707. So it will be 2 pi into 1.3 7.45 into minus 3 minus 2 10 to the power minus 48. No, 59. 23, 23, yes. 46 minus 3, 59. 10 to the power minus 59. 46 minus 3, 59. 10 to the power minus 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. 59. I put the answer. So it is 6.626 into 10 to the power minus 34 divided by 2.3081 into 10 to the power minus 23. So it is 2.870 into 10 to the power minus 11. Is it matching?
I got different.
You got different.
Yes, sir.
What is the value? Which one?
1.87 into 10 to the power minus 12.
Okay, what value you got different? H is the same, I think. H same 2 pi. Because
Total
M,
answer.
M you consider this?
Which one?
M.
Yes.
This is KB. T is 3700. Then why it's not matching? Let me check again. 2 pi 1 to 10 to the power minus 3 into 1.38 into 10 to the power minus 23 into 3700 divided by 6.0 minus 20 10 to the power 20.
It is approximately same. So what is the problem?
No, power 10 to the minus 11. No, I'm getting the same value. Don't know.
I also get it, but I get 1.87.
1.87 into 10 to the power
10 to
11
the
or
power
12.
minus 10 to the power minus 11, but 1.87.
Okay, that may be some error, but 10 to the power minus 12 it should be. Na? Here we obtain 10 to the power minus 12 meter. See?
I am doing it again.
Okay, probably in question also there may be some wrong data may be there. But we have to consider only the this way. This is the straightforward here. QP equals to V by lambda cube. Just do using this because this question I take from previous year question of CSI net. So there this was the answer. Okay. So probably here hydrogen atom is mentioned. Maybe H2 gas. It maybe we don't know. So probably something may be there. So better to consider this formula. This will be the answer. Okay. So now question number 10. So this will be our last question probably. Check it. Question number 10. It is 4. Yes, last question. This is easy. Let me do it like that. Okay. Let me, okay, let me check the question. Internal energy you didn't study, right? So, 6. Yes, this is okay. Two identical particles have to be distributed in 3 energy levels. The ratio of the probability that the two particles occupy same state to the probability that the two particles occupy different states for Bose-Einstein and Fermi-Dirac statistics will be. Okay, so
Too much stuff.
not too much stuff. Just
Bose
read it.
Einstein Fermi-Dirac.
Bose-Einstein Fermi-Dirac we have discussed in the last class. Nothing is there. This is very easy question. This means we have to consider the particle are indistinguishable.
Oh,
And we know that Fermi-Dirac case, for Fermi-Dirac, no particle will be in the same state. Two particle.
yes.
So that we have to just do it. What we have to find out the ratio of the probability that two particles occupy the same state to the two particles occupy the different state. This ratio we have to find out. So let's say these particles of having in the same state is rho s, s for same, and this is rho d, rho or rho instead of rho p, ps and pd. Okay, so we have to find out ps divided by pd, first considering the Bose-Einstein, and then ps divided by pd for Fermi-Dirac. This is the question. So now two identical particles are there, uh, and three energy levels are there. Okay. Okay, so there are three energy levels. We don't know the value of energies, and we know two particles are there. So what will be the number of arrangements for Bose-Einstein cases? If there are two particles, let's say two particles may be there, or this is another combination. We just find out the number of arrangements, right? This is arrangement. We are now considering first the Bose-Einstein. In Bose-Einstein, there is no restriction. One combination is this. These are called microstate. I'm not using the term. These all probable orientation are called microstate. This is another one. And this is just any other probability is there.
No.
So eventually 6 probability will be there only. Okay. So now we have to find out the probability PS when the both particles in the same state, right? PS is the when the two particles are the same state. So what will be the probability?
1:1.
No, 3 by 6. Just check.
Yes, and the PD also is 3/6.
Yes, and the PD is also 3 by 6.
So 1:1.
So PS by PD for Bose-Einstein case will be 1. See, there is nothing. Question is formatted like very tough, but just we have to find out
Yes,
the
very
arrangements.
simple.
And Fermi-Dirac, what will be the answer?
It will be 3.
Just look for Fermi-Dirac cases. What will be the changes?
No two
Fermi
can in the same state.
This will be not there, right? So Fermi-Dirac cases, PS will be
0.
no PS same state, so it is 0 by 3, correct? So 0, and PD is 3 by 3, so it is 1. So PS by PD for Fermi-Dirac is
0:1.
0 by 1, so it is 0. So nothing. Very straightforward, very these are called very sweet question, because if you crack it, then it is easy. Nothing to calculate, nothing to do.
Yes.
Just you have to understand the question. What does it mean? Okay. So probably, okay. So 10 question we have discussed today. So, okay, let me say if there is any doubt regarding today's questions. Uh, In next class, probably the internal energy and other things will be introduced. So next class, all things will be more complicated. Okay.
Can you please tell some book or other study source?
Study source for the statistical mechanics.
Yes.
I made my note for CSI net that I can provide to you. That was my study source for statistical mechanics.
Please,
That
I will be highly obliged then.
okay. Then I will provided you. And I will upload that note into my drive, okay, so that anybody can access that. But that will not thoroughly from these lectures, okay, because that I made for myself from various videos, YouTube videos, and various other books, and my class note also there. But my class note is not relevant for CSI net, because um, I studied statistical mechanics or statistical thermodynamics in special MSc special. So that is quite more difficult, quite more rigorous. So that I don't provide you, because that will not be relevant for you as well. But the note I made for CSI net, that is much more sensible and matches with these things. Okay, so that I will provide.
Also, any lecture other than English language?
So I followed that channel. One channel is there in YouTube, J Chemistry. So from J Chemistry, you can see give the lecture in Hindi. Okay. So I mainly prepare those notes from her lecture and my class notes. So from there, I made these notes that I will provide it. And let's see what the how the course is going on. If the course involves so much in details, let's say that delta function like things that's are also there. So in that case, I will provide you my class note even as well. But for timing now, I will give you the my CSI net. Yes. And you can
When
download that.
when will I get this?
Uh, I will upload that in. There is a spreadsheet right here. There is a drive link. So in the drive link, you will also get these lecture notes, what I did today or last day. That is also uploaded there. So from there you can check. So in that drive link, I will upload. Okay.
Okay.
And the spreadsheet link is also given to you, all of you.
Which link?
There is an Excel link in course. You can check. There is Excel link. You have provided this meeting link, and the Excel link also is there. The spreadsheet link. In that
That
spreadsheet
there
link,
is only this link only.
okay, they did not provide you any spreadsheet link.
No.
How? I don't know. We have to upload these video lectures. We have to record this lecture, and we have to upload that in YouTube, and YouTube video link. We have to put in that spreadsheet every week. Probably it's there. You can check in the NPTEL website or the SWAM app. Provide. I think that should be there. I will check. Otherwise, or you
I
can
have
mail them.
Swayam app.
But please check in NPTEL website. Just go into that course, and probably there may be the link is there, because in last course I checked, link is there. So in link we have to also upload that these PDFs and these video lectures. You will that we have to keep track. We have to upload that. Otherwise, I will share you in WhatsApp, but that is not case. In that video lecture, that spreadsheet should be available to you students basically. From there, he or she can go through the video lectures, right? Otherwise, what's the sense to record this lecture?
Okay.
Okay, so I will upload it there. Okay, okay. So let me stop sharing.
Thank you.
Welcome. Okay, so we'll meet again next week at 4 p.m. Okay, so okay, so now we can Cliff. Okay, if you have any doubt, you can ask me in the next class regarding next week lectures. Okay.
Okay.